By the end of this tutorial, you'll be able to use the particle shape scaling capability to quickly set up 3 different simulations and understand how particle shape affects the material's porosity. In this example, the properties and interactions for both bulk and equipment materials have been defined. We have imported 3 different CAD particle shapes into EDEM. It's good practice to rename the imported particles. Next, navigate to the size distribution section for each particle and adjust the shape scaling parameters. We are increasing the size of the imported particles in the X direction. Ensure that you have applied the same shape scale settings to the other 2 particles. Next, move to the geometry section. We created 2 plates, named top and bottom, with the dimensions shown here. We adjusted their positions along the Z-axis. Next, we have to add motions to the plates so that they compress the bulk material we will generate. To do that, we add a force controller to each plate with a defined force, working in the opposite direction. Next, generate the particles in the simulation. To do this, create a virtual box with the following dimensions. Then, use the volume packing tool to create the particles. This tool will fill the geometry box, using a defined solid fraction. For this example, we'll use 25%. Next, move to the physics section. Select the base and friction models for the simulation. We set the following input parameters for the Edinburgh contact model for this tutorial. If you need further information about any EDEM contact model, please check our e-learning courses and documentation. Under the Environment section, select the X and Y axes since we are simulating only a small portion of a larger system. Once your simulation is set up in the Creator, move to the simulator to start processing. Set the runtime to 0.15 seconds. We're using the GPU solver to run the simulation. More information about the GPU solver is available in the EDEM e-learning and documentation. Here we can see the bulk material created with the 3 base particle shapes we defined. The original shapes have been elongated in the X direction for all particles. Also, we can observe the 2 plates compressing the bulk material. Before moving on to the analyst, we will create 2 more simulations. To do this, go back to the Creator and set the time step to 0, so we can run the simulation again with a different particle size. For this second simulation, we will use a shape scale value of 1. Update the shape scale value for particles 2 and 3. Save this second simulation, as we aim to have 3 simulations to compare the influence of particle size on the porosity values. Next, repeat the same procedure to further reduce the particle size by setting the shape scale value to 0.5. Save the simulation. Then move to the simulator to start processing, in a similar way to how we did the first simulation. In the EDEM Analyst, you can adjust the visualization of geometries and particles using various attributes. We'll hide the particles to allow you to easily visualize the continuum item that will be created. We'll focus on the continuum analysis capability, which allows you to understand the effect of particle size on the porosity of the bulk material. First, add a continuum item. Next, add a mesh by introducing a plane. This plane is placed at the center of the simulation domain. For this example, we'll add only one plane, however, multiple planes can be used. You can adjust the plane's dimensions, position, and rotation, and the number of points to increase the evaluation resolution of the continuum data. The particle data can be evaluated at each node in the plane's mesh. Once the plane is set up, generate the continuum data by selecting a static analysis and choosing the last time step. Under Attributes, select Porosity. In this simulation, we set the cutoff distance to 6 times the average particle radius. You can change the display options and add a legend. Next, we can compare the 3 simulations to see how continuum analysis is used to visualize particle effect, specifically porosity, that might not be obvious through standard particle visualization. Here, we can observe the different particle shapes created by changing only the shape scale factor, which allowed us to quickly set up 3 simulations. Next, we'll visualize the continuum data created to understand how particle shape affects bulk material porosity. We observe areas exhibiting high porosity values at larger shape scale settings. However, porosity is affected by various factors, and the planes presented here reflect only the central slice of the entire bulk material simulated.